In this video, we are learning lesson 7.3, linear functions. Okay, remember we've been learning about functions, and if something's a function, that means that each input goes to only one output. We've heard of the word linear before. We've seen that word in previous chapters. And you see that in the word linear, the word line is in the word linear. Okay? Linear means a straight line. Okay, and today we're going to learn about linear functions. So, our objective is I will identify linear functions when given a set of ordered pairs and a table of values. Okay, so we're going to figure out, how do I know when I see a linear function? When you're given a set of ordered pairs is example number 1. And example number 2 is all about when you're given a table of values, how you know if it's a linear function or not. Okay, our essential question is, how do you know if a function is a linear function? All right, and the way that you know that is the definition of a linear function is that it has a constant rate of change. Okay, a linear function has a constant rate of change. Now, you might be wondering, well, what is a rate of change? Okay, so a rate of change is the same thing as slope. Same exact thing. The rate of change is the slope. Remember, the slope is the vertical change. So write this down, over the horizontal change. It's the vertical change over the horizontal change. Remember, we learned it as the terms that the slope is the rise over the run. Right, because the rise is the vertical change, that's up and down, and the run is the horizontal change, that's left to right. So, rate of change is the same thing as slope, and we know that a linear function has a constant rate of change. So we're going to look at two different functions, two different sets of ordered pairs, and the example says, does the set of ordered pairs represent a linear function? In the first set of ordered pairs, when we graph it, it's going to be a linear function. The second one is not. So I'm going to show you what a linear function looks like, and then what a function looks like if it's not linear. So here we have a set of ordered pairs, and we want to know, is this set of ordered pairs, does it represent a linear function? And two things need to be true. First of all, when we graph these set of ordered pairs, it must be a straight line. Okay, just like at the beginning of the lesson I said, remember what the word linear means. It means a straight line. And then the other thing that must be true, if it's a straight line, it has a constant slope, which is your rise over your run. All right, the slope must be constant. It has to be the same between any 2 points, because that's what makes a straight line. All right, so let's start graphing our set of ordered pairs to see if it graphs as a straight line and that there's a constant slope. So the first ordered pair is -1, 3. So let me plot that, -1, 3. My second ordered pair is 0, 5. So I'm at 0, 5. My third ordered pair is 1, 7. So I'm going to go over 1 and up 7. 2 comma 9, I'm going to go over 2 and up 9. And then 3 comma 11, I'm going to go over 3 and up 11. All right, let me take a straight edge here. I'm going to, okay. Notice it looks like a straight line. My graph does look like a straight line. Okay, our y-intercept is 5. And we have to make sure that there's a constant slope, meaning the rise and the run is going to be the same between any 2 points to make sure that it is, yes, it is a linear function. So let's figure this out. So let's start our first point. The rise, we go up 1, 2. So the rise is 2. And then, so we go up to rise 1, 2, and then run 1. The run is 1. We go up to 1, 2, over 1. Let's see if it's the same between all the rest of the points. We go, let's look between the next 2 points now, what the rise and the run is. We go up 1, 2, over 1. Up 1, 2, over 1. Up 1, 2, over 1. If you notice, the slope between any 2 points is the same. The rise is always 2, and the run is always 1. Okay, so there's a constant rate of change. So the rate of change here, which we said is the same thing as a slope, the rate of change is 2. All right, because the rise is 2 and the run is 1. 2 divided by 1 is 2. So yes, this is a linear function because it makes a straight line and there's a constant slope. The slope between any 2 points is 2 over 1, 2 over 1, 2 over 1. So that's the rate of change is 2. This now is not going to be a linear function, this set of ordered pairs. Okay, so this is a new problem. Let's graph. This is going to be no. All right, something that's not a linear function, let's write this down, is not a straight line. When you graph the points, it's not a straight line, and the slope is not constant, meaning it's not going to be the same between all points. So let's graph them, the set of ordered pairs, to show that it's not a straight line and the constant isn't slope. 0, 0, let's plot that. 1, 1, so we go over 1 and up 1. 2, 4, we're going to go over 2 and up 4. And then 3, 9, we're going to go over 3 and up to 9. Okay, if you notice, let me draw the lines through each of the points. All right, notice that is not a straight line. It curves. So this is not a linear function because the definition of a linear function is it has to be a straight line with a constant rate of change, a constant slope. Here, it's a curved line, and we'll notice the slope is not constant. Let's check the slope between every point, every set of 2 points. So here's my first 2 points. Look, the rise is, we go up 1 and over 1. So it's 1 over 1. Then the next 2 points, we have to go up 1, 2, 3, and then over 1. So now the slope between these 2 points is 3 over 1. Then here, the slope between these 2 points, we go up 1, 2, 3, 4, 5, and over 1. So the slope here is 5 over 1. So there isn't a constant slope. There is not a constant rate of change. So no, because there is not a constant rate of change. right? Because the rate of change of the slope is not constant, so it's not a linear function. Okay, make sure you have all those notes, and then you want to try the got it number 1, and then watch the video to make sure that you have the got it number 1 correct.